Hello, guys, and welcome to day 2 of video write-ups. Today we are joined with Stas Rakovsky, aka Hexadecimal. Stas, wave your hand. Where are you? Great.
I'm
And
here.
Artur Khanov, aka Avengar. So I don't have any extra stuff to begin with today, so just let's begin. Today's first challenge that we will cover is rebyC medium CatGirl Breach. It is a status challenge, so Stas, I'm handing it to you. Let's begin.
Okay. Hello, everybody. We have a exe file. It has pretty good name do not pet me.exe and has a cat as an icon. It's pretty efficient for our organization because of we use cats to produce cat girls. Okay, what is this file? We can just run it, but because of it's a ransomware that clips our precious file, we first of all should investigate it, for example, using detected easy. It says that it's Acronis installer. It's obviously wrong. It's just a WinRAR SFX archive. SFX is self-extracting archive. You can also open this file using binwalk and see that there is a zip archive at the end of file named madoka.bat and named shieldhero.vbs. It's pretty interesting names for attributing. We can open this file using WinRAR archivator. So let's do it. Open the SFX files will not run it, so we can freely open it without any fears. So we have SFX script here. We can see that after the unpacking these files at the current directory, it will be hidden using attrib plus hide to shield hero to Madoka, and after this will be run file named shieldhero.vbs using silent and override modes. Let's there is a decrypted files, decompressed files. Let's look at shield hero. Well, so we have just 4 lines VBS script that silently run CMD script without any icons, any forms opened. Because of if you just run this file using using SFX script, you will have a icon CMD, and it's it's unnecessary for us if we want to run it silently. So look at madoka.bat. It's huge script. It's actually but less than 40 megabytes. It's actually a shell2exe generated script. This utility uses .exe file to make it to make from this bat file. We have file 456 and will run this hash values in this. We have additionally attrib.hash added by our bad guys to hide the file. While it's decompressing very long. It takes a lot of time to decompress, and it actually has a lot of load. So people, so humans that run this file can now can notice that the huge file was opened. And at the end of the script, we have PowerShell.exe that splits the file and run it. Okay, what's the run script? The third layer, it's just a file main.exe. We can see that it's a PyInstaller logo. Actually, when we can see PyInstaller logo, we can use PyInstructor. We can use PyInstaller utility to view the archive. Let's use PyInstaller, PyInstructor to extract this file. A bit like VBS about main.exe files. It's actually a runner and overlay with a lot of the lib archives that has .py, .pyc, .pid, and other files, Python runtime for running the script. So let's run PyInstructor to decompress. Okay, we have a big problem. This PyInstaller uses Python version 3.8. It's quite new version, and we can meet problem with it because of probably there's the tools to work with big file will not assist us. So we have successfully decompressed it. We have a quite project, and we have the main file main.pyc. We can see this that PyInstaller bootstrap, the kinter. I don't know why it was packed with my not my but bad guys project. I have multiprocessing. We have main.pyc. Okay, we need to convert pyc to py file. You can see that this folder named the fourth layer bet because of uncompiled 6 in current version, developer version from Git cannot decompress it, no, can decompile it. Let's try it. So we have a problem. Code indicator is unexpected. We can open it in people who work with PyC files using this tool can know that there is in Python 3 16 bytes of magic, 4 bytes of signature, 4 bytes of timestamp, 8 free bytes, and there is an actual start of code object in Python. So we can try to strip this information, save the file, and try again. But uncompiled 6 says that he doesn't know the magic code E3 or 227. So we can't use uncompiled 6. Okay, we can try another. We know that there is a PyC code object. We can unmarshal it and work with it using this. So we have actually a file named python 38.dll in our unpacked variant. So we can use the library that's supposed to be using to run this PyC file to it will help us to properly unpack the file and do not meet any problem because of its legacy file for it. It is not Python 2.7, Python 3.6, but a problem with uncompiled 6 doesn't depend of Python version, and Python 3.8 also do not help us to uncompile it. Okay, we can use modulus marshal and this from Python to extract Python object. We can download portable Python 3.8 and copy from them files python 3.dll and python.exe to run this Python interpreter using Python 3.8 library. But we have a problem. Пап, подожди. Пап, я занят 15 минут. Да, хорошо, это кошки утащили. So we have a problem because of actually portable Python is 32-bit, but Python 3.8.dll used by this program is 64-bit, and we have exception. But we can download and run the proper version, the proper byteness of Python, and we have a shell of Python 3.1, 3.8.1 of this actual DLL. We can use in this moment uncompile 6 to unmarshal this file and obtain a py file, but it will also do not work. You can just believe me because of I prepared this right up and I tried it. We will run the proper version and use this and marshal. Marshal open .py in byte mode. Shit. Так. RB. Okay, we have no any problem. We need to strip the first 16 bytes because of its magic of file, but not magic of code object. And we can use this to obtain a Python bytecode like just line strings. Okay, it's a Python bytecode. What we can, wow, it's a huge. We can see constant pretty lead. It constant will be written to variable ergarden. We have a huge constant to the variable so cute. We have actually uncute. We have some cycle, range, len of scute up to 60, and it's the body of this cycle. And at the end of file, we have exec, compile, bytes, uncute passwords. So people who solve tasks on JavaScript that uses execution function exec to write the next stage of shellcode, not shellcode, but just plain code, know that we can redefine exec function to log warning, log info, and obtain the next stage of the obfuscated code. So we can also use this trick in this situation, just exec equals print. But to run this unmarshaled file, we also need exec, but we redefined it, and we can't use it from it, but we can import built-in. So import. Okay, and we have exec unrated. It's actual built-in function exec. We can use it. And exec used by this program was redefined. Let's check the current state of local variables. Run, then marshaled code. Okay, the function print that was actually exec printed to us a code object. We can recheck the locals and have nothing. It's not right. Globals. I think it should be compiled probably. Compile in exec mode. It's quite strange because I thought it should work. I used exec redefined. Built-in exec. Built-in exec. Too silly. Okay, we have file cute password. We have new locals variables. We have uncute that actually decrypted code. Let's just join it. Okay, it looks like a job for me. Here equals print here. Okay, this looks like a last stage of our ransomware. We have usage of kernel 32. We have type, struct. We have some XOR using 2 bytes of 2-byte key to decrypt something. We have some YouTube links. We have quite good variable pet the cat. We have some key preparation. We have a pretty strange algorithm with a magic number. We can Google it. And we actually can some seeds, strange seeds. We have another function. We have extensions. We have starts with. Let's define Higurashi. It has no any destruction functions. It just decrypts strings, so we can define it. We can obtain the information what extensions this program expect. It expects .catGirl, .cats, .flex. Okay, starts with. Probably it will check the start of file and encrypt file this that starts with this bytes. The flag is CyBRICS, classified property by CatGirl Industrials. Okay, we have the main cycle that will iterate the current files in this folder and in other folder inside this folder. Iterate files, join, shifter state. If the name of this file ends with one of these extensions, we will shifter. If this file starts with the expected strings here, the file will also be encrypted. Okay, we will encrypt it using function vakatara, and it uses a pretty strange mode. It reads the file, jumps to 0, and writes it. It's in mode of R plus B. It means write. It means read binary plus write. This way we can open this file only one time to read and write this file at the same time. Okay. After this, files that should not be encrypted, he will hide using kernel 32 function of WinIP set file attribute A or W with status or word 2, that means hide. And at the all folders, he will open the file in, I think, hackett.txt in write mode, and he will put the text you were hacked. Okay, we have an attribution, secret attack organization, sent a lot of dollars to pet the cat. To pet the cat wasn't defined. To, okay, we have a we have no escape. We cannot decompress this file. We cannot decrypt this file because we have no way to связаться, to send the money to our bad guys. and it's pretty bad. Okay, we have no hope. We can just try and examine this crypto algorithm to try to decrypt it. Okay, we have pre-generated key. It is 1, 2, 3 variables. Define it. Pretty strange names of variables, I think. Okay, it doesn't copy. Let's generate the key for us using our bare hands, because I don't want to run this code. Okay, we have a key, and we have an entry of encryption function named Vakata. We have a padding, simple padding using 0 bytes. We have a using struct model to split this file to two words, little endian. Okay. It splits the file, and after this, it will encrypt our pair of the words using this algorithm. And after this, it will just split it. And the end of algorithm will write our file using this encrypted information. Okay, let's examine the stage 1 encryption 8 algorithm. We have obfuscated variables, distracting variables, stage actor, pnow, pyow, mic, miu, and strange algorithm. It's actually a key algorithm, tiny encryption algorithm with broken constant, because of original algorithm uses as a delta constant variable ends by 9. We have ends by 8, and it will prevent us to use an open implementation of key to decompress it, because of add the decryption, not decompress, but decryption, because of the main logic of algorithm is that we have a sum, we have a calculation, and we have a usage of sum in this algorithm, and sum is a increment of delta at the each of 32 rounds. So we here have also 22 iterations, but we have a broken constant. This way, this sum does not work, won't work. Sorry for my English. We need to recalculate it. Okay. Let's move to the future, and we actually have this file written by us that has recalculation. What does it actually do? We have this function quite stripped. We only have things that we need, because of sum depends only on this variable delta. We can so process sum and delta to the function, and prepare for us a new values. We can use key I to run a interactive mode after the script completion. We can also just run Python and import decrypt.py. Okay, let's recalculate it. So we have sum 0 and delta this value. At the end of this algorithm, we will have a recalculated sum value for decryption function. So what we just need to do to have a decryption function, we can Google it. We can use a free implementation in Wikipedia, but we have a strange padding used by this function, and we also need here to look at padding. So I will use a implementation of the algorithm on Python and just redefine sum and delta values. So let's run it. I have a decryption manager. It actually looks like equal as this function, but just decrypt it. Let's run our deck manager. Crypt is open our top secret flag. .txt in byte mode. Okay. Also, we need to have a key. We have calculated it. It's this key. Op. Okay, we have a key. We have a sum value. We have a delta. It will be unchanged, but we should use a delta from our ransomware code. I can just copy it from here and try to decrypt it. Okay, we have actually decrypted flag. Meow joined CatGirl Industrial. It's our secret information that was encrypted by this ransomware algorithm. So at the end, summing up, we have a SFX archive that contains a VBS and CMD script. CMD script is actually a shell-to-exe proceed exe file. The exe file is actually a Pwnogram with new version of Python that's the way we cannot use our usual tools to get a code of encryption, but our bad guys use encryption, so we can extract the last stage of code. We can analyze that there is a obfuscated key algorithm using a broken constant. We can actually do not know that this is a key. We can just like a black box revert these operations, because of you can just make it in reverted order and plus You can revert this algorithm and obtain the flag without knowing that there is a T algorithm. So that's all.
Great. Okay, thank you. So, oh, by the way, I have another thing to add. Do you want me to show you how to uncompile it with uncompile? Let me show you real quick. So we got.
I actually have problem. If you have problem. No?
Okay, no, it seems okay. It's okay. So we have this
You
main.pyc.
wanted to.
I guess we get some latency or something. Anyway, we have this PyC starting with E3 byte, and we need to uncompile it using version 3.8. And for this, like to not invent out of our head what headers we should add, I just take some random Python file and compile it. I run Python 3.8, compile all, compile it, get file in PyCache folder, which is PyC for that version of Python. And it already has a correct header and starts, like the actual code starts with E3. So let's just do some transplantation, copy from here, and paste to here. Here we go, and let's try running on compile 6 on that. And yeah, it's decompiled successfully. We have the Evergarden assignment and the So Cute, which is then stored and exec, like this.
Wow.
Okay, so the next challenge is, where is it? Network Medium Moneylovers by Artur.
Yes, I'm here. Okay, Moneylovers. Moneylovers is net
Medium.
Net medium is net. No, net
200.
This net. Okay.
You should also start the screen sharing.
Yes. Okay.
By the way, if you have any questions, feel free to ask them in YouTube
screen.
chat. Yep, great.
Yes, you see my screen. Okay. Moneylovers is a task where you guess the pickup file. Let me show you my pickup file. Okay. Pickup. Here you see that somebody exchanges data with some server. It has IP 95, 217, 22, and 76. Let's go to this IP address, and yes, and we see. And we see that here we have some site with HTTP protocol. Of course, a certificate was generated manually, and here we can type some symbols by clicking to image with keyboard. Okay, also we can delete symbols, and what's more, some participants cannot continue to work with this task, but the typical pen testing action is, of course, scanning. Yes, Let's go and scan and map, and this IP address. After this, we can see that the server has HTTP S port and FTP port. Let's go and try to go to FTP and this server. Yes. Here we can see log.txt. Log.txt. Of course, I already downloaded this file. Let's look at this file. Here we see that this is like client handshake secrets. It was pre-shared case for Wireshark. To apply this, let's right-click, open transport layer security preferences, and select pre-shared key pre-master secret log file. Here we can see that HTTP protocol packets appeared. Of course, we can just filter this, but if we follow these packets, then we see that somebody try to enter this page, and after that, somebody posts some values to this server. Here you must look at this body, and you see that it just click coordinates. Server returns the current line of entered case. You must map these coordinates to this keyboard, and click appropriate case in this keyboard. How to do that? Just go and try. Let's go and try to enter correct case. If you look at server source, you will see that it just verifies that current string corresponds to the predefined value, and after that, it just returns flag. I will enter this value on keyboard. Okay. Sometimes it's too hard because of network delays. 6G W P 9 V Y space W 7 S G W 3 space X 5 B S 0 F T space B J 1 U W F 4 B 4 R K 2 M O. Yes, and get flag. This was a flag. One more way to solve this task is just to repeat these posts. You can just enter to the server and repeat all post packages in some utility. It means that you may not recognize actual symbols. You may just repeat these packages. I think no questions. Yes, we can continue.
Yep, we have no questions. So let's continue. And the next one will be, according to the schedule, web medium walk. Well, actually, I should like to stretch our brains, quickly show something about web hunt, and then we will proceed with walk. About web hunt, very quickly. So we have a page, which is, by the way, like courtesy to Matthew Rayfield, who made the capture hunt. And like we need to check 5 recaptures. I know some guys just caught them and pressed the button, but I'd like to show you some interesting way like that I found. If we turn off the position absolute attribute on capture class, we just get this and we can comfortably check all the 5 captures. Actually, there is a second way. This one is like a client-side developer way. There is also a server-side developer way. When we press get flag button, we get redirected to get price.php with a G recapture response of some long value, and this value is actually pipe pipe character delimited recapture responses. We can just solve one capture and send our server script this one capture 5 times. So, like, let's solve one. Let me cache it. Traffic lights, bicycles. Great, I have one. Then, like, not to start burp, I can just look at responses variable. And responses plus equals responses. I got 8 of the same response. Now get flag. Oh, hell. It seems like get flag button doesn't read the responses variable. Okay, once again. But I think you already got the idea. Here. Oh, I hate it when reCAPTCHA does this. Okay. And responses, up. Got several responses. Now check any other one. Great. And get flag. Awesome. We just multiplied one value and used it several times. That was quick 2 ways of solving web baby hunt. Now to the web medium world of calculators. So what do we have here? We have a link to the website and source code. The link to the website that allows us to create and share calculators. Let's play with it around a little bit. So let's register. Now we get to choose a calculator template, for example, this one. It works. We can just like do some maths with it. Okay. Also, we have an option to share the calculator, which gives us a link. The link, by the way, ends in .php. So it seems like it drops a PHP file when we do sharing. And also, we have an option to create our own template. which is an HTML file. So, how to solve it? Let's go to world of calculators. I think the first thing we should look at is, let me open it in the correct notepad, is the share link. When we press share, we enter this branch of code. So first we should pass this regular expression, and then we get the PHP script creation with some HTML JavaScript tag with inserted PHP tag, then some static library, also HTML and JavaScript, and then the chosen calculator template, which we can create a new one. I saw many teams boggled by this regular expression. Actually, it's it's not the thing that we should worry about, but I can show you that it's really pretty simple. Let's copy it somewhere else. This regular expression is broken into two parts. It consists of two parts. The one in these brackets and this one starting with circumflex and ending with a dollar. Let's break it into two parts. The first part is a non-capturing group. It's how is it called in regular expression? I don't know. Like it says that the next text should match this regular expression, but it doesn't like consume the characters which it has matched. This one is really simple. It's start of text, end of text, and between start of end, we have a group which is repeated any number of times, which says the whole text should consist of either a series of those characters, which includes mathematical expressions, brackets, and like decimal point, or digits, or some like English words, which is the pi constant, the earliest constant, some functions, arc sine, like hyperbolic or something. So it just tells us what expression we can write into our calculator. This one is more obscure, but it just checks the balance of the brackets. So we can't like do this. We should do this. Also, we can't do this. It's just a recursive regular expression that checks the balance of the brackets. So I saw some teams like grinding. Can they bypass this regular expression to put some PHP code there? But no, they cannot. Then, when we press share and pass this regular expression, our shared expression on this calculator gets written into a PHP file. First one, we get the field that we have posted inside the PHP tag. Then we append some static stuff and a template. We cannot put anything evil inside this field to execute arbitrary PHP code. So the real thing to do is to figure out what can we construct out of those mathematical expressions and symbols to leverage it to do something interesting. And it turns out that the opening comment tag is first. It consists of just two mathematical symbols, division and multiplication, and also it has precedence over PHP ending tag. So if we say like open the comment, not close it, and close the PHP tag, the closing PHP tag actually doesn't get parsed by PHP, and we bypass the closing tag. So if we open the tag here, we get all these part ignored, and we finally control our template. And in our template, we can close the multi-line comment and write some PHP code. Like I see, if we ignore all of that, we need to tell PHP what to cast as a string. For example, 1. We need to close this bracket. We need to close this bracket. And now we can write like semicolon and PHP info or something else. And for example, close the PHP tag, which we haven't closed here. This will be in our template. By the way, about the template, it actually doesn't allow us to put an opening PHP tag here, so that we like can't just put some PHP code inside the PHP file. But there are like no limitations whatsoever. In addition to this, we just need to have some required blocks, and that's pretty much it. We just create the new template as is. So let's put it to work. Let's break it. Actually, not to like put all of those manually, I just copy one of the existing templates. I like the iPhone one. Just copying the existing template, make a new one, make it, give it a new title. The title tag is used as a template name on the main page. Close the comment, and actually let's copy what we have written here. Maybe we should do PHP info, but like evaluate, get e, the get parameter that we will pass to the script. We create the template. Here it is. It was written. We have our extra code in the end, because we have no like opening comment. Let's quickly send an opening comment. We remove the read-only attribute. Enter opening comment, and let's share this expression. Now, in this file, we have an opening comment, a closing comment, and our eval. We open it, we get nothing, and we see a PHP warning in the source code. So our code has executed. We can do like e equals PHP info, and we get PHP info. Also, we get just comment execution. Listing the root folder. Here's our flag, and cat flag. Great. We have pwned the world of calculators. Alrighty. I think I'm done here. Let's see whether we have some questions. No. Great. And the next one should be, who's the next one? It's CyBRICS Serial and CyBR Hard Botmaster by Artur. Artur?
Yes, I'm here.
Great.
I'm sharing screen. Okay, first is serial. Serial. It was. Yes, it was serial. Cyber 100. Let's look at the task. At first, you get something like this. This is a simple page with 3 fields. 1, 2, 3. Yes, in the serial. Also, you get this source code. This is the source code of this page. You see that it just verifies that A, B, and C fields are less than 1 million and are in 3° plus B in 3° equals C in 3°. It looks like impossible, yes? If you try to enter such restrictions to something like Z3, you will get that it has no solutions. But such numbers exist. What are these numbers? Let's look at solution and enter these numbers. Okay, it has solution, but what's wrong? Yes, if you try to find these numbers in Google, you will see that you will see what's wrong with JavaScript. This, yes. The subject is about data types in JavaScript. If you try to compute this, for example, in Python, you will see a very big number, yes. Of course, it exceeds 4 byte. And if we have long numbers in Python, we have no long numbers in JavaScript. In JavaScript, it will be number with floating point structure. And as we know that in floating point case, we have precision miscellaneous. You see that in case of JavaScript, these numbers are equal. But if we go to Python, we see that this expression equals to this number. It's more precise result than this result. It was task on this feature of JavaScript. Any more explanation required or not?
I think there are no questions. We actually can use
no
like
questions.
just some large number and a 1.
Some large number and a 1. Maybe such numbers exist. Of course, you may just try to brute force this task because it supposes that numbers million from 1 to 1 million. It was also restricted with 1 million. Yes. Okay, let's continue. Next task. Yes. Next task, Botmaster. 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 In case of Botmaster, you get some memory dump. I will open my solution notes. Okay. Wait. Yes. Okay. You get this memory image, and if you go and try to define what is the type of this image, you will see that it's just a Windows 7 32-bit. Okay, let's try to run volatility. -f and this file, and minus profile, this profile, pass list. And after that, we see that in this host, the next list of processes was run. Wait. Yes. And yes, this list of processes was run. You can try to find some suspicious processes, and you will see that there is one suspicious process is wait, this process. Where is it? Bot. That's the host. That's the host. Bot exe. This process. Of course, it's a suspicious process, but in another case, you can try to define it by some strange name or strange path. It was a simple task. I may write driver, I may write process, and I may inject process in another process, but it was simply bot exam. Of course, after that, you must try to dump this process to continue to reverse this. To dump this process, you may enter next command. Pass list, and command is proc dump. Proc dump means the dump to point the folder and pit of process to 444, this process. After that, you get executable for this bot.exe. I will interrupt this because I already dumped this process. If you just go to strings, you will see that somewhere here we can find some IP address. If you go to this IP address, you will see forbidden. Yes, you must continue to reverse this application. Open it in IDA and look at its content. And if you go to look at this content, you will find that this is botnet. It's open source botnet, just a GitHub project with panel and with Visual Studio project, which contains the sources of bot. Also, you can find here that you must go to login page. Login. Also, you can just dirbust this login page, and you can find that you must enter some login or password. If you try to find some vulnerabilities here, it will be no vulnerabilities here, but you can download sources of this panel, source code of this panel. Just contains the PHP code. You may follow the several ways. For example, first, you may try to read sources and try to find vulnerabilities in sources. Go here, try to find here vulnerabilities. Another way, you may try to find diffs with original sources from GitHub. And you can find that in one of files here, some modifications was made. It looks like the author of these sources tried to leave some backdoors in these sources. Here, I commented the parameter placement in PHP code and changed it to variable substitution of RAM. And of course, here we have insert SQL injection. This injection allows me to go to find something in database. Okay, but if you look at these UBOT sources, you will see also that protocol of interaction with this server is encrypted with XCorp algorithm. Actually, dump. No. Actually, you must XOR your package with predefined key. I'll show you. Look, if you want to send something to this Botmaster, you must place the X token header with encryption key. But if you place 0 key, then of course you may just send raw packages. Of course, packages must be URL encoded. Okay, now I just can try to send the package which initiates the interaction with command center by bot. You can obtain this package by running bot.exe on your virtual machine. And in Wireshark, you will see such packages. In RAM header, you may just leave some SQL injection. Here is my injection. It just selects password from user table. You may understand that user table exists in SQL database from, for example, from our sources. In both panel sources, some default tables creates user table. Of course, I changed this and I changed this. Here you can see that we have username and password table. For my attack, I just used update XML to return me field with password for some user, for example, for root user. If I run this attack 1, I will get the password for user root. I can change this to, for example, user name. Yes, it's a username. I must change it on my server. Username. Username is root and password for root is password123. Let's go to panel and enter this panel 123. Oh, capture, yes. No capture. Yes, we entered to Botmaster panel. Here I just added one bot and left flag in his log file. Log file is like keylogger logs for us. This is it. This was a flag. And what are these machines? These machines from participants. They tried to hack this, but by some reason it doesn't succeed. Okay, it's all for now. Yes.
Yeah, we seem to have no questions. Did those participants like leave their keylogs too? Did they get some key grabbed by the keylogger?
Oh, when I run this task, when I prepare this task, I grabbed keys from my virtual machine. From another participants, it was no logs.
Oh, okay.
They didn't run keylogger. To run keylogger here, I must run
run command.
this create command and next.
Oh, okay. So it's pretty benign, not evil. Okay. Binary says in the chat, very interesting. Thank you. Let's proceed. We actually get Igor here on stage. And the next task is Reverse Hard, hacked again by me. Like as a tradition, let's start with some baby challenge, reby's baby, Hellish Reverse, and then Rev Hard. So, what we have in reby's baby, where it is, Hellish Reverse, we have Artur GZ, like in every challenge on CyBRICS. And actually, if we just expand the archive, we get a Python script. Let's open it in the correct notepad, which is just it's ridiculous. It like verifies the format of the input, which is 44 characters long. Then it hashes it like with ton of hashes, and if the hash matches, then it's correct, and that's all. It's kind of silly to think that we can brute force it or something, because come on, those hashes, that length, no chance. So the idea was that gzip, gnuzip, gzip leaves the internal, the inside file name just like as it is when packing any file. So we can show this, for example, by running the file command. And the file command tells us that it's zip compressed data, and the file name inside is in the clear text, and this is the flag. We can just open it like as hexes. The file name is a clear text. In Total Commander, we can just enter the archive. The internal file name is as clear text. So many ways to solve this one. Those were the ways to solve Hellish Reverse. Now, Reverse Hard, hacked again. What do we have here? Reverse Hard, hacked again. So the legend is that some guys were hacked. They give us access to their hacked server, and they give us some log file. First, let's look at the log. In the log, we see that it begins with like mid-April with one IP address reporting to the command and control server, which is C2 CNC. Then on the 12th of June, we get sudden burst of several IP addresses, and slowly, steadily, towards the end of the July, we again have only two IP addresses reporting to the command and control server. First is our hacked address, .94, which is also we are given access to, and the second is the original one that was reporting at the very beginning. Also, one can notice that every report happens once every 4 hours. Also, if we scroll to the beginning, we see that in the beginning, the reports happened once every 4 hours, but also there were some like interruptions, some peculiarities in that. Like the legend was that this portion corresponds to the malware author debugging his backdoor on his own machine. And then once it's like stable, he began infecting the servers, many servers. Then their admins were patching the servers, removing the backdoor, and in the end, only us and the malware author have remained. So currently, the backdoor is active on our machine and the malware author's machine. Also, if we follow the malware author's IP address, we can scan it. There is only SSH port and HTTP port open. There is some guy's landing page or something, which is clearly like malware oriented, black hat oriented, and we get a link to private docs right here, which is temporary files, don't enter for my convenience, and it's basic authentication protected. All right. In the task, we are said that we want to know the malware author's identity, so probably the private docs folder is our target. Alrighty, let's examine what we have on the hacked machine. Let's log in via SSH. We get root. We have SSH daemon listening here, and that's all. Well, we can look around on the system, and actually, by looking around for some time, we can see that we have LDSO preload file, which lists libraries that will be preloaded automatically into every process that uses dynamic linker. Normally, there is nothing in such file. For example, on my machine, I do not have any LDSO preload, and this is a frequent way of persistence on Linux systems. Let's look what this library is. This library exists, 30 kilobytes, and actually libz, okay, it's zlib for encryption for compression. But actually no, the real libz points to libzso127, and we have an extra file, libzso1.2, which is also July 14th. Not long after we get LDSO preload, so that's malware. We can confirm this by examining what's loaded inside SSHD by looking at the memory mappings. And here we have libz. It's really loaded inside our SSH daemon. So let's download libz. We have internet access here, so we can exfiltrate it via TCP. Just send it over to our port, or we can, for example, output some base64 and copy paste it and decode it locally. I have the library downloaded to my machine already. So let's open it in IDE. This is quite a big library. There is a lot of code, and this start entry point is actually fake. It's just a random function that's typical for libraries. And the real function that gets control when we inject this library is the init proc, is the constructor or initializer of this library. And also it's exported as SSH init. I guess so, or I don't know why it shows here SSH init but not there, but I think it was an export. And init-proc is again a large function, and if we look at it superstitiously, we can pinpoint some portions that it compares something with Cafe Babe. If it's not, then it won't execute anything further. This one probably results from this function call. This function, it looks like some cryptography. So probably it decrypts here probably 128 something bytes. Then it checks some signature, and then it has some also comparison inside memory with unconstant, which is actually ELF. So it looks for ELF file beginning. It is scanning the memory downwards in page granularity, and once it has found it, it begins reading the ELF parameters and actually patching and installing hooks. It's installing hooks in the process by patching its memory. Also, if we open strings, we see here that we get several strings related to SSH, like read passphrase, SSH user auth2, etc. So this is a library that implements an SSHD backdoor by patching SSHD right in the memory. It's actually in the wild malware, a real malware, which is like used by the bad guys. So as long as it patches our SSH daemon, let's just dump the SSH daemon which is running here to just get the patched version. Let's get the maps. Here is the SSH daemon memory mappings. Here is the code, the one that is executable. So we will dump this portion. I think I will just use dd to read from the mem file. Block size will be 1 page. We will seek to the start. dd accepts it's in block count, so we should like drop the 3 zeros. Count will be the ending address without 3 zeros minus the beginning address. What else? And output file to memdump. We have 820 kilobytes dumped. Do we have hex dump? No. Well, we will just I guess output it as base 64. Oh, okay. We get too little memory actually for XZ, and we have no bzip. Let's use gzip. Great. We have our base 64 blob. Let's copy it. Let's create memdump and drop the base 64 into it. Oh, only 363. Oh, because it's gzipped. Okay, let's decompress it. Yay, we get 820 kilobytes. All right. Actually, it looks pretty patched already because it should start with ELF, with the ELF header, since it's mapped from the ELF binary, but it does not. Let's load it into IDA. I will load it into IDA. Alrighty. I'm not showing you IDA just yet, letting it finish its analysis. It will finish like in a couple of seconds. And it's done. Here it is. So we see that right at the beginning, right at the address 0, we have some trampolines, some function jump trampolines. For example, at address 0, we get jump to keyword 6, which contains some address. At the next address, we get jump to keyword 16, which again contains some address. First of all, what are those addresses? So it is 7F, B8, 4EE, 4. Let's consult our mappings. once again, B8 for E, E4, 6. B8 for E, E4, 6. Okay, it lies in this region, and it is our backdoor library. So the backdoor library has patched the SSHD memory to contain some pointers into its code. All right, nasty library. We can actually see what this function address is corresponding to. We know that ASLR doesn't affect two lower nibbles, so let's just search for any function that ends with 280. There is one. Okay, looks like this one is being called once we jump to address 0 inside our SSH process. And how do we jump to address 0? We actually have a code xref to address 0 here. So, all right, it looks like our SSH backdoor has patched the call to address 0 inside some function. Let's look at what this function is. We see that there is SSH connection string. Actually, if we return to the assembly, there is one more string, input user auth request, invalid user, and we can actually use SSH sources to locate what this function is. We have OpenSSH 7.4 on the server, which can be verified by running something that will output the SSH server version. So I've downloaded the corresponding sources from the OpenSSH website, and let's find the input user auth request string. Let's grab it. All right, we get one result. We get one result in auth2.c. Auth2.c. Let's find the string, and here it is. Here is our strcmp with SSH connection that we have here. strcmp with SSH connection, and here is our patched call. So strcmp, one call before that, and the patched call before that. strcmp, one call before that, and patched call before that. So our backdoor has hooked the get Pwnogram allow function, which accepts one parameter, which is user. And user is a string, a pointer to char. So sub-0, this function is hook get Pwnogram allow, and it accepts user. So it actually duplicates the user string, stores it in some global variable, so it's some user, and finally it returns some keyword, which is probably, since it's hook, which is probably original pointer to the original get Pwnogram allow. So we can do this to restore all the hooks made by this backdoor library. I actually have an IDB with some more renamed functions. And the interesting functions to us, since we want to get access to malware author server, is where the credentials are checked, where SSH daemon checks whether it should allow the user to access the server, to get shell. So we get first this hook in authentication via password. And we see that the password, which is passed by the user, is being CRC32'd. CRC of the password is being calculated, and if it matches v4, which is some config password CRC, some value in the malware config, then it returns 1, which is success. So it overrides the password authentication to return success if the password that the user has specified matches the CRC32 inside the config. And it also sets a flag is owner that disables logs and stuff. So that malware author, once he accesses his backdoor, he won't be getting into logs. So great. Probably we can dump the runtime config, get the password CRC, and then brute force some password that matches this CRC. Our next step is dumping the runtime config. Runtime config starts at offset this one. So let's dump it just right from memory. Here is the offset that our library starts. Let's again use DD. And oops. Actually, we need to add some offset, which is 207. 207. The count will be just one page. We can specify like a fractional offset to just dump A40, which we will need. So we will just dump single page and then look at it in a hex dump. Here is our memory page with the config. Let's insert it into hex editor. And our config will be at offset A40. Let's scroll to offset A40. Here it is. First, we can notice Kefi Babe is here, so the signature is matching. We have some command and control server IP address in clear. We can reverse other values, but we are now interested in password CRC, which is at offset 4, just right after the signature. And it is 0. Oh, hell. That's bad luck, because when the password CRC is 0, this branch will not be executed. But if we look at another hooks, such as the function which is checking whether a public key is allowed, it turns out that there is another check. There is a check that some pointer, some data chunk, being CRC32, gives another CRC from config, which is public key CRC. Well, we already reversed that. And public key CRC, which is just right after password CRC, is actually set in our running config. So it looks like this SSH backdoor will authenticate us successfully if we try to authenticate with SSH private key, which public key has CRC32 of this value. So essentially, we need to forge SSH private key, for which the public key has CRC32 of 5033 0B D7. This is all that this task is about. Well, also reversing, but like the second crypto part, or crypto-ish part. So actually, that's not too hard to do. First, we will do some brute forcing for that. First, like the CRC32 can be pretty easily set to be a certain value by tools like CRC hack. CRC hack just accepts some data blob, like what, like here is an example, hello, and it can set its CRC32 to any value by appending data or by replacing data. so that the results in CRC32 will be just what we need. Second, we can we should get a key which has its public key match the CRC, but what to do next? We need a private key to actually authenticate to SSH servers. So we just convert the public key to private. How? Well, for RSA keys, we just factorize it. And we can use, I actually used a tool called Yahoo, which is yet another factorizer or something to factor the modulus of the private key, of the public key to get private. And third, I actually used RSA CTF tool to recreate the private key in the correct format from the two multipliers of the public key. So we actually generate just some random SSH key. Actually, I used 1024 bits, so it is smaller, so it is just faster factorized and stuff. And I have mutated this modulus in this public key to contain some random data every time. Like I mutated probably 16 bytes in the middle, and I used CRC hack to make it match the CRC32 we did. And then on the modified modulus, I used Yahoo to factorize the modulus and get the private key. This way, it works probably around 5 minutes. Like the brute force should try around, I think, 1,000 attempts on my machine. After that, we get what we need. We get a public key with needed CRC32. Actually, I have the files here. So this file should have a correct CRC32. If we convert it to hex, we see that it is indeed 50D7. Here it is in text public format, and here is the corresponding private key that RSA CTF tool has given us. So we should be able actually to log into that server using this RSA private key. Let's test. I'll just drop my private key just right on the hacked machine to check. Let's log into localhost, and we're in. Yeah, exactly. We are in through SSH. Great. Our private key worked. Now, the moment of truth. Let's try the same private key to the malware author's machine, which is in the logs. And yeah, we are in. Great. We're on the malware author's machine. We get SSHD. Also, we get testing.so. Okay, you nasty guy. We get Nginx, which is serving the web server. Let's look at the Nginx. What configuration does it have? Conf.d or something? No. nginx.conf. All right, location private docs has authentication enabled, and the actual HTML root is USR share. Okay, here we have private docs. Aha, here is his driver's license. And we can actually download it by using the same base64. Okay, getting some lags. Where does it start? Here. Driver's license.jpg. Let's drop it and let's view it. Great. Gotcha. That's all. Thank you. That was Reverse Hard hacked again with an SSH backdoor. I'm moving away all the windows. And the next one will be after I check the questions in YouTube. Do we have steganography as tasks? Not this year. Okay. The next test will be Artur's network baby, XCorp. And Artur, I'm giving it to you.
Yes, I'm here. XCorp. Yes, XCorp. In XCorp, you get this log file. And here you can see that we have SMB file exchange. If you look at this, you will see that somebody just goes to log into some page. Let's look at expected objects in SMB. Okay, we see that we can export net10.exe several times. Yes, for example, 22 kilobytes is it looks like the more fitable for export. Just save all here. Also, if we run this, we see that it asks us some username. Of course, if you try to reverse this, you will see that it just try to decode this with some password, with entered password. The task was to understand what password you what username you must enter here. But if you remember the process of SMB introduction, you will see that somebody wants to enter to this host with the next username. Let's copy this. And try to enter Ultra Hacker as password. Of course, it was a password. If we enter some another password, it will be incorrect. But here is our flag. Of course, you must you cannot copy just copy it because it was a label. You must type it in your keyboard. It's all about this task. It was very simple. And next task is Krevedka. Krevedka was forensic task. As I remember, yes, it was a forensic task. You just get the next pickup file. What's happening here? Here you see that somebody tried to enter to some site. This site was run in neighbor computer, and somebody just iterates users to enter to this site. Of course, actually no logic located in this site, just login form. And also, you provided with information that some user, Kalicious, was hacked by some hacker. You must understand who hacked Kalicious. Let's look at packages. HTTP, which contains Kalicious. After this filtering, you will see all packages with Kalicious substring. Kalicious, but this package looks stranger, yes? Let's follow this HTTP thread and see. And you see that somebody tries to apply SQL injection here, and somebody tries to define the attacker by source port. It was an invalid way. You must define this by this string. If we copy user agent, you can just go to HTTP contains this string, and you see that some user tried to enter server with this user agent. This user was Micropetaulus. Micropetaulus was the answer. Micropetaulus, but with CyBRICS, of course. It was answer. Maybe any questions? No questions. It was also simple, but must find the appropriate data to select user. I think for this task, it's also finished.
Great. Let me restart my microphone. All right, my microphone has restarted. We get less lag. So the next challenge will be, since we have no questions in the YouTube chat, will be CTB Medium Whale Corp, also by me. Let's go. What we have here, Whale Corp. So we get just some access to SSH and the pointer that the flag is in root flag. Let's access the SSH. All right, what we have here, we have, we are a limited user. We have a cron daemon. Let's look at cron tab. Okay, every minute, under root user, a script opt deploy.py is getting run, and right next to the script is data directory, which is writable by everyone, so we can create new files in it. And there is deploy.py script. Let's quickly analyze what it does, since it's run by root every minute. Let's look at the script. So, okay, it gets opt data directory listing. Every file that it will process should begin with lib and have .so. in its name. Then it opens this file. It checks that the owner of this file is root. It checks that this file is not writable by anyone else, group or others. It reads the content of this file and closes it. All right. So we somehow need a root-owned file that we cannot write. Now, it checks that the new content starts with ELF signature, actually. It checks that inside the system library folder, there is a file with the same name as the file inside the opt-data folder. And actually then it drops the new content from our file to the system library folder with that name. So actually we can, using this script, drop any library in place of any existing library on the system. All right, that looks promising, because if we can replace any library, then we can basically get root, because there are some setuid files. For example, su. Let's find all the setuid files. What setuid files do we have? Okay, here is the list. And for example, let's take su. Let's look at what libraries does it load. And for example, if we somehow manage to replace libpam with our code, then our code will be run as root once we execute su, which is sweet. All right, so maybe my way of solving this task is not the only one. I don't know, but the essence of this task is to somehow create a file owned by root, but without controlled content. Also, which will be essentially an ELF. So there are strict restrictions on the headers. So we can't, for example, use some logs or something. So let me show you my solution. I will actually use the following interesting property. For example, I have executed some sleep process, and I'll be targeting the cmd line file, well, sudo file for this process. This cmd line sudo file is owned by the same user as the user that is running the process. For example, here cron runs as root, and his cmd line is owned as root. We can actually read the cmd line, and let's read the cmd line of our sleep. We get first argument, which is the binary name, then a 0 byte, a null byte, then the first argument, or second is first starting with 0, and the 0 byte. Actually, it turns out, can we do this? Yes. Actually, it turns out that every argument inside the cmd line is terminated with a 0 byte. Okay. Also, we can, for example, do something like this: su root, and then any number of extra arguments. And then we get a file owned by root that contains our content, our controlled content. But we have several obstacles. First obstacle is it starts with su. We can overcome this by just using bash construction exec -a, which allows us to specify another argv0 root and other stuff. And we see that instead of SU, we get our controlled word. Here it is. Also, we can actually use not just ASCII characters, but actually any binary character except for 0 byte. But we get 0 bytes for free just by terminating the arguments. The bash syntax for this is like this. So for example, 7f, elf, or something. Su, root. Let's pass 01, 02, 03. We can make consecutive 0 bytes by passing empty arguments. I have passed 5. And for example, FF, FE. Okay, this looks strange in the PS output, but if we look at this under hex, it's pretty normal. It's got elf header, it's got consecutive 0 bytes, it's got the binary bytes just there as we need them, and the last obstacle that is remaining is the following. If we run SU and pass first argument to not be an existent username, like this one, the SU exits right away. It just tells us that user does not exist, and it bails out. And that sucks, because actually, if we look at, for example, bin SU as an example of an elf file, we see that it starts with some elf header, then it gets 1 0 bytes, and then it requires another 0 byte. So the second argument should be empty. So we can get 2 consecutive 0 bytes. So we should actually start SU like this. SU, then an empty argument, and then some other control arguments. And SU just bails out. Empty user does not exist, and it exits. But there is a way to circumvent that. It's a pretty dumb way. Let's just execute SU in a loop like this, and then press Ctrl-Z to stop some process. And we actually get a process run by root, which we have stopped. And we get the needed consecutive 0 bytes. Great. Now, putting it all together, we will spawn a SU binary, and we will stuff it with our arguments so that the CMD line pseudo file will be some library with our code. Let's look at how we can do this. First of all, we have prepared lib.c, which is just one function with attribute constructor, so it will be run once the library is loaded, which does setUID 0, just like gets the full-on root privileges, not just effective user ID, which will be dropped by bash. And then it copies bin bash to tmp bash and sets suid to the tmp bash. So it creates a suid shell for us. I have compiled it just with GCC, got a so file, which is an elf. And actually, I converted the so file contents to a corresponding exec arguments for bash. So once I encounter a 0 byte, I put an argument to an end. So consecutive arguments become consecutive 0 bytes become consecutive empty arguments, and all that stuff. So there is this 26 kilobytes command line. Let's execute our trick, which is while true do exec this thing. Oh, actually, I think I need to open the bracket. If we don't open the bracket, exec will just replace our bash, and it will execute only once and exit. Okay, actually I'm not using su, I'm using password, so it prints its help when given too much arguments, and I'm pressing Ctrl-Z. All right, where it is. Actually, I think I got unlucky, so I need to foreground our while true. Try once again, Ctrl-Z. Now I get lucky. Here is our root-owned process with some trash as the command line. Okay, looks like a binary. Let's actually calculate its MD5 sum. It starts with 16 2 to 6. And the MD5 sum of this one is 16 2 to 6. Great! We got bit by bit exact copy of the library inside a command line. And only one thing remains. Okay, we get a minute to spare. We can make a symlink to that CMD line in our data directory, and we should call it something like, for example, libaudit.so.1, which is actually libaudit.so.100. Okay. libaudit.so.100. We have symlinked it to our CMD line. So now this file will be our library, and we should wait 20 seconds more for the script to fire. And then, for hopefully, we will get our original libaudit replaced by our library contents. So original libaudit is 133 kilobytes. It should have already been fired. Okay, yay! 7 kilobytes, great. Now let's run su. It asks for passwords. We just Ctrl-C it. And we remember that it should have copied bash to TMP. All right, we got a root suite bash. Let's run it. Oh, actually, let's run it with -p argument so that it doesn't drop the suite permissions. We get effective UID of root, and let's go into the root folder and cat flag. Great. We have raised our permissions to root by exploiting a cron script. That's all for this task. Let me drag the windows out. And the next task will be, let's see, CTB Hard Pwnogram by Grok, which is the Pwn task for which the second part was not solved during the CTF. It was probably really hard.
Is my micro working? Yes?
Yes.
Oh, cool. So let's begin. In this task, we were given some tar archive with Docker file and a client for Messenger. So I created some simple Messenger, and your first goal was to attack and capture the Messenger server. So we firstly open Messenger's binary in IDA and start analyze it. It have about 1,700 functions, but most of them are automatically generated and not needed. One noticeable class, I guess, will be resource manager. So we can try to filter functions related to this resource manager. So we can see that there's exist add user, user exist functions, create chat, join chat, and so on. So also we need to do some reverse engineering in order to understand how protocol is working actually. But we can do this analysis on the client side also, and maybe it will be a bit simpler because it's written in C. So maybe less some boilerplate code existed. Where the vulnerability in server was, actually, if we see the function delete message, we can see that this function accepts username, chat name, and ID, message ID, which need to be deleted. Then we check that user exists. Then we extract chat, and we call chat delete msg function. This function is just proxy for message storage remove message method. And if we analyze this code, we could understand that in message storage class, there are just a list with message pointers. And when we trying to delete message, we just iterate over this vector and trying to find the message with needed ID. Also, we're checking that this message was written by our user, and then we call method virtual method release, which is set this active to 0, but the message pointer wasn't removed from the vector itself. So actually, and there is no any checks in the code here that message active is equal to 1. So we can delete message, for example, twice and get the error, I guess, something like double free of corruption or something like that. Also, there's exist function, for example, send text, I guess we need not send text message, but get chat message, which accept chat name and ID, and extracting the message from the vector of messages. And it also doesn't check any except ID. So we could delete message and be able to read the content of this message, which is actually now can be memory of some other object. Same way we can rewrite this content using edit text msg function, as we can see here. Sorry, only one restriction exists. This is some size checking, but it can be easily bypassed. So how we could attack this? Here's my simple POC script for getting arbitrary read-write primitive in binary and leaking some base. So what we should do? Here a bunch of just simple helper functions which implements basic client functionality. So first of all, I connect to the server and register user. Then I create one chat and create another one chat. Then I create some message in chat one, which is called actually croak. Oh, I should name it a bit more verbose, but anyway, then I extract messages from this first chat and delete first message. What I do next, I forward this message from using the same ID from chat 1 to chat 2. So here, when I trying to read this second chat, I will read the memory of free chunk. Let insert return here and try to run this code in return outside function. We can always do 0 divide 0, and we need arguments. So this is OK message. Oh, this is actually not reading the message because this is this function is used for switching between the chats. So now I switch to second chat. Here I get IDs of messages in this chat, and here I read message with ID 0. Actually, this is not the same as ID from here because of I read ID messages of messages here. So we need to rerun server because of I used hard-coded username and chat name, and server forbids us to use the same. And I forgot to save. So we can see here that this is probably is a pointer to somewhere in a heap. Oh, actually not. And here's another pointer. Now we are able to, if we see last 2 bytes, we can notice that it have 840. And actually, if we look at the binary and trying to find where the virtual table for message exists, we could notice that. Let's try to find message constructor, I guess. Message. Here it is. Address of message virtual table is on page is 840. So as we can see here, actually we are already leaked binary address, so we can deduce binary base from here. And this is actually a pointer to the heap of one of the worker threads, which are used to react on messages which are coming from the socket. So next, this is some code which are doing some heap grooming, but maybe it's unnecessary actually. It just added new messages to the first chat in order to achieve actually a situation which we already achieved, because we already have another message object allocated inside the message content of our all deleted messages. And now we using so I have, I guess it called wanted here. It's the ID of first original deleted message, and using this ID we are able to fake not only the virtual table of victim message, but also the pointer of victim message and its size. This is done here. So again, because of no function checking that messages are already deleted in our server code, we are able to edit message using this message ID. So we can create, we could rewrite the existing message object. Here we save the virtual table address as it was usual, and here I rewrote the pointer to the message content to base address plus this value, which is actually in some offset from the base to the God section. And I say that the size of this message is actually 100 bytes in hexadecimal. So again, let's do 0 divided by 0 and rerun our exploit. And again, I need to add my break here, because here I just edited the message, and after that I edited the message in first chat, but then I trying to read message in second chat, and this is a message already controlled by me. So as we can see here, we are successfully leaked content of some memory from the GOT table. So we leaked libc base, and here I do similar stuff in order to show you that I also able. Here I got arbitrary read actually, and here I got arbitrary write actually. I will rerun my server with GDB in order to show you that I actually really got an arbitrary write. So I start my exploit. I again forgot to save it. Rerun server, run exploit. So now I get in the base. Oh, actually, I have binary base from here, and I use x that slash duality x or x and plus. And we can see that in the memory we actually now have 3 A's, which was my payload. All we should do now when we have arbitrary read write is just, for example, we could just rewrite free hook with system address, and this is a way to get to, and then try to free some message with our shell command. So, for example, this is how we can read first flag. But if we try to read what we should do next, next we should do attack on messenger client. So a better way, I guess, will be, for example, create some fake rope chain somewhere in the memory, and then rewrite free hook to pivot to this location, and then you will be able to do almost anything. I think it's not very interesting. It's just a routine, maybe. Second task actually was, in my opinion, a bit more interesting and a way more hard by accident. I made some mistake in my code, so instead of just heap overflow, the task is now of Pwnogram client is actually consist of so vulnerable function was first vulnerable function was I guess read MSG list. Here read read list, just read list. So what we could do here, we allocate some objects which is used binary compiled with debug information, so doesn't need to reverse this binary. What we could do here, enable to achieve leak some memory. We could pass these elements as any value, non-zero, for example, 20, and then we write in socket just 1 byte. So this read will read only 1 byte, and this memory after allocation will be contains, for example, some pointers to backward libc metadata. This is actually very often situation when you could achieve some leaks from allocated chunk which are not properly initialized. So, for example, to patch this vulnerability, we could adding memset here or something like that, or we could try until we reach all MSG length bytes. So this is how we are able to achieve leak of some addresses. In my second exploit for client, I have function which is called send malformed list, which is send size, amount of elements in ID list, and small string which is used to satisfy the read call. And second vulnerability exists in the readMSG function. What's happened here? Here we read sender size from the user, and then we malloc sender size +1 bytes. Actually, original idea was that we could pass -1 here, so malloc from 0 return some valid chunk, and here we could do overflow. But actually, Linux kernel checks this and just returns error. But we still have another option. If we pass big enough sender size here, malloc will return 0 for us, and at this read will not crash because again kernel do some checks. So read with buffer equals to 0, just return error, and this string is actually now become something like that: sender size so we write 1 byte equal to 0 to any memory controlled by attacker. And also we already have a leak, so we know where the heap exists, where libc exists. What we could do, how we can use it. My idea was following. So I guess I can just run client. I run, I guess, server here and run client here in GDB in order to show what will be happened. So, I guess I should make font a bit more, a bit bigger. So I create some user. Let's create some chat. Let's send some message to the chat. And now let's see what happened in bins here. We can see that after some operation which a client is doing, we have filled tcache bins. And my idea was to rewrite less significant byte of some pointer in this tcache list to 0. So let's show you by example. So I dump some heap memory here, and if I overwrite it less significant byte with 0, it will be pointed here to another memory. And so via some heap feng shui, we can able to reach situation where when this rewritten pointer will be pointed to our memory which we are controlling. But there is another problem now appears because after the read MSG function is finished, there will be called function called add message from the server, and here will be called to strlen with which will be center field of our structure will be passed. But as we remember here, a center field is equal to 0, right? So in order to bypass this problem, we should not only just rewrite some tcache such way that it will be point to our controlled memory, but also after rewriting, we should be pointing before the location of this allocated structure. So I guess I could show it by running my exploit. I just need to find. So what this exploit is doing. First of all, he creates some listening socket. Then it waits for connection. This is how client bot was working. Actually, when you connect to the port 3333, this script is running in Docker, so it just using Docker hard-coded IP and port which is provided by you, and run client with these parameters and create a random login, create random chat, and then just starting to asking for all messages. If we look at client code, option number 9 is just asking for messages from the chat, and if some messages exist, it will be request these messages. So my fake server actually just first he sent OK to login to register message, then he sent OK to the message with create chat command, and then when we receive the message to provide the list with ID of messages in this chat, we send our malformed list. Actually, this is done because of first part of our heap massage. So then for all messages, I answer no. Why this code exists? I need to allocate some chunk and achieve such situation where the structure called one moment here this structure called message underscore 0 in IDA. This structure should be allocated after this chunk in memory. So that's why here I just send no, because of if we look at the code here, we here create list, but if and then trying to asking for messages for all IDs in this list if this ID not already existed in binary, and we will be creating this object only if server says OK to request of the message. If server says no, then this code we actually jump into this control path, so this code will not be executed. And when then next we will allocate a message underscore MSG object, it will be located after this chunk actually. So here I just use this calculation to say that I need a chunk size 300F0, 3F0. Okay. Then I again send another malformed list with another ID, and this here we are creating some message, actually only one message with for ID equals 8 bytes with 80 byte. And also here I just print some leak, so we could again let's do, for example, sysexit. I guess it will be a bit more right way. Let's run our server. H fake lock, maybe call it. So client because I run it by hand, I just emulate how the checker script is working. So I create a random name of 16 bytes. I create chat with size of 16 bytes. And here we could see that actually else is executed. That's because of my fake servers always send no in first loop for asking a message. Now I again asking messages, and we are leaked some memory. If we are not. Oh, I guess we could verify that we are leaking some interesting memory from client maps. Yes. So 56 or 3, 18. 56, as we can see here, the leaked address is from heap. Why is this address is from heap? Because of we are this chunk after free will going into the cache. So that's why heap pointer is appeared here. Then I using almost same technique to leak libc and actually heap address. I create a chunk with a size 440. Why I choose this size? Because of I didn't want that my chunk will go to the cache. So I create this chunk, and I guess now we should play. We are now using this exit here, and if we run this code again. Just need to wait some time. Now I press 9, just as bot is doing. Again, press now 9, and again, I guess, and again, and here we can see two printed numbers. This is a libc base. This is a heap base, and after that, actually. Attack will be started. So let's inspect in GDB what is a bin layout before bin memory layout before executing our last step. So let's replace sys exit to pose function from pwndbg pwn tools. Let's also okay. Let's run listening netcat because there's no any return. Now we are running now fake server, running client, tink, tink, tink. No, I guess I should add some print in order to no, it's okay. Press 9 again, press 9. So let's look at the bins now. We already have in case of my server, we always have this chunk. This chunk will be used as a message underscore msg allocated object because of there's only one allocation exists of such size, and when I send my messages, I also try not to use this size. And we will be rewriting this this pointer from tcache, and we will be rewrite last byte from D0 to 00. Oops. Take. So this is where tcache head is pointing now for chunks with size 210. And this is where it will be pointing after my attack is done. Here, right now, there are zeros here, but before attack, I also will create another. I again use same malformed list function with same size as at first step, as if you remember, because of this chunk is placed right before the chunk, this actually chunk with the address of allocated MSG_MSG message. And then in this chunk, I already starting to attack here, so I prepare some cmd command to be executed, make it padded by 8, and here this is just free hook minus length of cmd command. It will be, I show later why I use this. So next we will be send this fake malformed list, and here where the attack begins. Actually, this is this is also already exists pause for us. So I guess we could do here. So now we will be do some stepping in GDB and see what has happened here. Okay. Here we return from first read in read MSG_MSG function. So we are now here. This is exactly the CMP with 3200. So let's do some stepping here. And now we will be allocating message_MSG structure. I guess that should make some alias for this name in my explanation, and it will be a bit more cleaner. Next, let's see what is RX value is now. The RX contains a return of the malloc function. So just as we planned, it's a chunk from Tcache with that address, and also we can see beans now. Nothing interesting here right now. Let's do some stepping again. Now we read, I believe, MSG type here. Then we read size of chunk which we want to allocate, and if we see here, now value RX register is equal to this value. Why I choose this value? Actually, if we read some glibc source, we can notice that init Tcache function is actually allocated one chunk from the heap, and then Tcache lists are stored in this memory. This can be validated, for example, like this. Let's read some memory from heap starting. Now we can see the chunk ABA0. Let's call beans command from PwGDB. This is a pointer equals to this pointer, right? So if we take the value from the exploit 188, we will see that this is a pointer 3D0 from this one Tcache list. Now let's see that malloc will return 0 for us. Now we will call read, which will be failed immediately with RX containing -1. And all magic will happen here. So let's check bins now. We should look at this one and execute this instruction and look at the bins again. And now we will see that actually we successfully rewrite least significant byte in Tcache in first, not in first, in pointer in head of this Tcache list to address near free hook. Next, we will read. Let's look at the memory layout of our MSG function now. Message underscore MSG structure. If I remember it correctly, it has this address. So this is a message type equals 7. This is a pointer which will be contains, I believe, body. We could verify it in IDA. And this yes, and this is our sender pointer, which is equal to 0 now. So the strlen call from addMSG from server will fail. But now we will call malloc. So in RIX we will see that RIX is pointing before our message underscore MSG structure, and we allocate chunk with size OX200. And the difference between this address and address of message underscore MSG is less than OX200. So when this read will be executed, we could validate. Then now we are contain some pointer here. How I get this pointer? Actually, because of heap state will be the same between runs, we could just inspect some memory in GDB and take some offsets from the heap base and use it here. So let me see. This line is used to fill my message content, which is already will be rewrite chunk. As we can see here, I restore chunk header, restore message type. This is the address heap offset to actually exactly the chunk which will be contains this data. This is why I add CMD here. And then again another chunk which will be used as a sender chunk and will be freed during the execution of this function, but it doesn't care. B doesn't care about this. So let's go to the add message from server function and verify that we will be successfully rewrite a free hook. This value here is offset to libc actually. It can be found, for example, like that. We could do p/x %system minus address of libc base, libc load address. So OX55410, exactly the same as here. Let's do some stepping here. We will skip add message function because it doesn't interesting for us. Now we will see that in RDI we actually have non-zero pointer, so strlen will not fail. Then we doing some malloc, again copy, and here we are using size of our message content, call malloc with size 201. And if we actually dbg already shows for me the value of arrayx register, but let's verify. At this malloc call, we given value from tcache. So when later this memcopy will be executed, it will actually write our message body inside of location near malloc hook. That's why here I use such calculations, because of I write my command to the libc memory and then rewrite free hook by system address and just go okay, go and in release msg function we could see that we call free with pointer which is pointed to my command. So if we go inside of free, we will see here we check that malloc hook existed, and now we'll jump to the system. So I guess we could just say okay, and my command successfully executed, so I get flag from the client. And how we should there's one step missing in my write-up for now. That is how we are able to fake server. But this is kind of easy. If we are already able to execute our code in server, we just could close the server listening socket and do exec, for example, I don't know, maybe bash with some command which will be exec system call. So it will be replaced our server, and we could download, for example, some Python script and run it. So this Python script will be listening same port as server does, and the client will be go and talk with this. And also I can verify that if I run my after talker, I guess it's called script, it also will be auto client. Let's run fake server. Let's run auto client. It should waiting for IP and I guess for port. So now let's wait. We have, I guess, 3 pause calls in my script now, in fake server script now. So we are leaking libc and heap base, done, and now we are again have flag. I guess that's all.
Looks great. All right, this was some hardcore pawning. Whew. Okay.
Oh.
So I think we got no questions on the YouTube chat. Thank you, Haru Lee and Geoffrey Chisnell. They say that the CTF and or the write-up was good. So with that, we only have 2 challenges left, actually. The first one being Network Easy, Google Cloud, and then we will be looking at Netflix. Let's start with Google Cloud. Let me drop some windows here. So Google Cloud, we are given an archive. Upon extracting it, we get a pickup, gcloud.pickup. We can look at it in Wireshark, and we just are giving tons of ping requests and replies to the Google DNS. And that's all that is here. That's all that our traffic dump consists of. So, what are in our ICMP data? We have some just all the bytes from 0 to FF. Here. Then, okay, here we have some text. And actually, the entire payload is text. The entire payload is text about PingFS True Cloud Storage by Eric Ekman. We actually can Google PingFS. It looks like there is some project that emulates a file system over pings. Actually, it's a pretty funny program. It's a Fuse file system driver that doesn't store the data anywhere. Doesn't store it in the memory, doesn't store it on disk, it doesn't store on anyone else's disk or memory. It just stores it in the network wires. The data only exists while it is flying over the network, so it sends a portion of file to the server. The server replies with the exact same data, and upon giving that reply, the PingFS server just again pings server with the same data. So it just reflects our data back and forth between the remote server. So I guess we need to somehow extract data from that PingFS protocol. And actually, PingFS protocol is just putting data in the ICMP payload. There's nothing like more to that. Actually, there were several files, most of them being just text files taken from the PingFS repository. Is just source code. For example, this one is a make file. And on top of that, there was some non-text. Okay, this is the portion of license, I guess. Also, there was some non-text files, which is this one, which is binary, has exif string, starts with FFD8, so it's a JPEG. It's a JPEG picture. All right, so let's begin extracting the data. Since we have lots and lots of packets, we need to somehow automate processing them. So I will gcloud. I will use tshark, read from the pickup. I will say to output the fields that I need, and I will need the field called data, which is the payload of the ICMP packets. I see here when I hover the mouse over this blob that I want to extract, it tells me right here that it is data.data. Maybe data will be better. All right. I get some columned data out. Let's actually, first of all, I think make it unique using an awk one-liner and save it to some file. Let's look at the file. What do we have here? Here we have some hex strings, and we got 105 unique hex strings. Okay, let's just eliminate the columns. Oh, okay, that was probably a bad idea. I pressed select all. I guess it will hang for a while. Maybe I should just force close it and reopen. Boom, where it is. Interesting. Okay. Here it is. All right, so then just replace it. replace the column with empty string. I'm just doing it so that we can unhex it easily. Okay, so now let's drop every content to the disk. For example, we can use I don't know, PHP. We'll just iterate the lines. Oh fuck, I've deleted everything. Okay, let's do it again. We'll just write to file named number.bin the unhexed value. Okay, we got those files. Let's look at those contents. Okay, just bytes. Pingfs. Aha. Okay, more and more of the same file. License, make file, license part. Okay, picture part. Some comments, some source code. Okay, looks like that's all we have. Let's now try to filter the text files, since they all seem to be just sources. Let's remove them. I'll be using file command and grep for text. When we have the text files, we will cut the just the file names like this and make xargs.rm, so we delete all the text files. We don't need them. And we are left with all the bytes, which is still just nonsense. We're deleting it. Okay, picture beginning. Next picture chunk, probably. Next one. Okay, we can see that the consecutive files contain more and more data. Their size gets larger. And once it reaches 124, a new chunk begins. So probably we should delete everything which is smaller than 124. Because those are partial chunks. And now, just let's add all those together. And it is a JPEG picture, so let's write it. All right, great. We have assembled us a picture with a flag. That was Google Cloud. Let's look at the questions. We have none. The next one will be networked hard, Netflix. Okay, let me close the files. And let's begin Netflix. So we're given access to some server with password QWERTY, and looks like we will be looking around. So the box is empty, but like we can make some use of it. Let's SSH into the box. Giving our team token. Waiting for some seconds for the environment to spawn. All right. We got nothing running. We got some nmap source code in the root folder. We are on .3 machine. And also, okay, we can look around in any way we want, but the correct way would be to scan the network. Let's first look what we have around us. And it actually turns out that we have 3 hosts up, which are .1 with all the ports filtered, it's just the gateway, .2 with SSH open and HTTP open, all right, .200 with no ports found, and the .3 that we are running on. Okay, let's look at what do we have on .2 over HTTP. Aha, there is some directory listing. I see index of /. Here we have some log files, some MP4, readme.txt. Okay, what's that? Okay, it's a Netflix CDN node, which has a little RAM, no disk, and it has flag on it. Okay, and we probably should get root on this exact node, on the .3 machine. All right, so it's diskless, it's low on RAM, and it serves some videos. Okay, so probably, since it has no disk, probably it should take those videos from somewhere. Let's again port scan this machine that we haven't made use of yet, and remove the port limitation. All right, we have an open port. We have an open port of iSCSI, which is like SCSI over network, which allows to publish and connect block devices, being disk drives, over the network. So probably this one is the network attached storage of the CDN node, or maybe the correct term is storage area network or something. So what we can do, we have 2 nodes in our close vicinity that one uses the iSCSI on the other machine. Actually, we can just use ARP spoofing to look at what traffic is going between them. We just, let's use some tool like EtherCap, which can do ARP spoofing. Okay, we select text only. Let's install text only EtherCap, and we'll be doing some ARP poisoning. Also, I like, do we have ngrep? No. I like ngrep, which sniffs the traffic and shows the strings that are flowing. Alrighty, so we'll be using Byobu. I'll split the screen. I'm pressing Ctrl+A%, and now we can switch between those 2 with shift arrows, which is really nice. And first, let's check whether we have IP forwarding enabled. Because when we ARP spoof them, they will treat us as the network gateway. They will route the traffic like through us, so we need to have forwarding to like not cut their connectivity. We have forwarding enabled. Okay, that's always the case when we have Docker, for example. So let's actually run EtherCap. Run EtherCap. What are the parameters? It said me to select user interface, which is text user interface. Next, meet them with ARP, meet on ARP. Next, I want only meet them with no other functionality of EtherCap because it just crashes with not only meet them. And then we should specify what to spoof. What are those IP addresses once again? So first one was .2 and second one was .200. Okay, EtherCap needs 3 slashes. I don't know what should come here, but all right. Activated the meet-em attack. Great. Let's listen with TCP dump what we have here. Not sure. TCP dump doesn't give us anything. Okay, so we have ARP flowing, which is also the effect of our TCP dump, or I mean our header cap. I'll also split the biob once again vertically by pressing Ctrl A and pipe symbol, so I can here like do some curls and stuff, like curl 2. Okay, now let's launch ngrep. We'll be grepping by just any value, and we are interested in host .200 to see the traffic flow into that host and from that host. Let's launch that and try to catch any traffic to verify that okay, nice. To verify that we can listen to iSCSI. Okay, we have some zeros. And actually, it looks like our CDN node has just written some HTTP logs to the network attached storage disk. See, we executed curl, and then after some time, when Linux wanted to actually flush the write buffers to the disk, we actually get some traffic to iSCSI, which I think says write this thing to some location on the disk. Great. So we get to listen to the traffic. Now let's see what we get when we try to access SSH on that server. Let's rewind it. Okay, it probably reads at hosts deny, hosts allow to. Okay, let's proceed connecting. All right, that was some binary. Oh my god, such a long binary. Okay, @kpmd, @kpmd. Okay, and some binary. Probably that's SSH binary, SSH daemon. Okay, some more. Aha, we got ourselves a shadow which contains password hashes, but we don't have any password hashes. Okay, so it does read shadow, but it doesn't read password, which is strange. But actually, it turns out that, for example, if we rerun the SSH and again try password, we do not get a shadow request. We don't get anything. That's because we do have some amount of RAM. We got 100 megabytes, and Linux just cached the password and shadow files into the file cache. Fortunately, we can evict files from file cache. For that, we need to convince Linux, like cache manager, that we need other file more than what we previously got in the cache. So we have 100 megabytes of RAM, and this file, for example, is more than we have RAM. So if we convince the Linux cache manager that we need this file more than password, then it will evict password from the cache, and the next time it is accessed, it will be requested from iSCSI. I will stop ngrep, and I will try to download this file many times in a row. 1, 2, 3, 4, 5, 6, 7. I'll just pipeline it. By doing this, we ask Nginx on that node to request the same file over and over again from the Linux kernel, and the Linux thinks that this file must be important. And now it has completely evicted for example, add password from the cache, when we rerun the SSH, after the SSH binary, which is also evicted, we get oh, come on. Maybe it was not after the SSH binary. Actually, we can, what is the starting bytes of password? It's root x00. Let's just grab by root x00. Okay. Nothing much, because we actually already got cached our etc password. Why do I say etc? Etc. password. Etc. password. All right. Stress this file once again. Let's try now. All right. We actually got etc. password right here in the traffic. So we took a look at shadow. We don't have any hashes like to brute force or something. But actually, like besides just looking at the traffic, we can actually actively modify it. This way, we can simulate a situation that we are like sitting on the channel between the system and its hard drive. And we can manipulate what is being read from the hard drive. For this, I used a script. Here it is, nf.py, which uses a Python library nfq to actually intercept and modify the packets, and Scapy to like parse the packets and recalculate the checksums, which is important. I will just, I think, install Python pip to be able to run this script, and I will install Scapy and fnfq Python modules. Meanwhile, let's take a look at what this script does. Actually, I googled it somewhere, maybe on Stack Overflow, and just patched in my modifications. The main logic is here. So if we get this substring in our packet payload, which is a part of etc. password, which is somewhere here, systemd network D, we will replace it. We'll replace this string with another string, user kek, password, actually password kek2. It's just a des hash of kek with the salt key and some UID. By the way, we can't just right away put here UID of root 0 because SSH has allow root login. No, it has root login disabled. So when we substitute this data into etc password, we'll be able to log in using user kek, password kek. Let's install Scapy and fnfq just quickly. And we also need to stress the cache once again. Do we have, okay, we have stressing the cache here. Let's run 1, 2, 3, 4, 5, 6, 7. And after we have stressed the cache enough to evict the password, we will run ngrep once again. Okay, it's just now showing us the flowing video file. It's finished. And we'll drop our nfq substituting exploit here. And we'll forward some traffic to the nfq. I actually do it with IP tables, jump to nfq, And also, I am looking for a particular string. So that's like I do not stress the nf.py too much. Once I apply it, the script is running. All the packets that contain this word go to the script, and we are ready to begin. Let's split it once again. We're ready to log in with user kek 2.2. Let's go. All right, we get modified password. By the way, here is our patch. Our kek user get patched in. We got replacing password from the script. We can interrupt the script and password kek. We are actually in. All right, we are in on fleeks CDN under user kek, but okay, we get nginx, but we still need to become root to get the flag. I saw some teams, maybe one team, for that also patching password and using su, because su just allows you to enter any user's password and log in as that user. But I actually, in my intended solution, did something different. Here is the second part of the script. It looks for some binary set of bytes and replaces them to another binary set of bytes. What that is? It's actually some content of unmount command of unmount binary. It's just the bytes at the entry point of unmount binary. So I'm just replacing the actual bytecode of entry point of unmount binary to execute my shellcode, which just does set UID 0 to become root and executes binsh. So when we substitute the bytes, just by running umount, we get a root shell because umount is suid. For this, I'll need to restart my script. But now I will need to grab another string in iptables. Let's run it. This one is armed to replace the umount bytecode. Let's run umount. All right, we are root. We have binsh running as a root. Let's interrupt the script and go to root. We have here waving flag.mp4. Just download it somewhere. And we get the flag. That's all. So this challenge was about what we can do when we are nearby a network booted machine and can do some ARP poisoning on it. Thank you for listening and thank you for taking part in CyBRICS. And let's check if we have some questions on YouTube. No. And I think the last thing that is remaining is some questions from the Google form. Let me find the questions from Google form. It's not easy. Meanwhile, while I'm at it, you can ask some additional questions on YouTube chat. Okay, I had it somewhere, but for some reason it's not there. So I will just go to the form itself and Look at the questions. Do I have any guys here too? Like Igor, Stas, Artur? Okay.
Yes, I'm here.
Great. Because there are some meta questions like some philosophical stuff. 1 second. There are 3 questions on the same topic. So the first one, actually, I will even share the screen. Let's do it like this. The first one is, how do I improve on web challenges and reversing? And some resources. Can you suggest some specific resources or tips for beginners to move into intermediate stage? And I'm still a beginner. Do you have any tips on how to approach these challenges? What do you think, guys?
I guess we have nice reversing challenges at Fork Bomb, I guess. I didn't remember the full URL. There's also some lections, but they're in Russian.
Yeah, if you can listen to Russian, go to our channel. Well, we're right now with our channel.
I can add. We have Practical Malware Analysis. It's a book about reversing malware. PMA, Practical Malware Analysis. We have Russian resource wasm.in that has a great content about reversing in IDA, in Gidra, in X64 debugger. We have I need to Google it. Reverse for Beginners book by a Russian.
I guess it's beginners.re.
Yeah, beginners.re.
Reverse
it's a free book about reverse engineering, not only for x64, x86, but ARM and MISP, I think, if I do not put in.
Okay. I will also recommend a Live Overflows channel. Probably you're more than familiar with him. He plays with Alice CTF team, and he makes great videos. I will also suggest that if you're a beginner, the only thing you can do to become intermediate and then expert is just to train a lot. Choose some portion of information security or what you're interested in, that you want to become good at, and just become a nerd, practicing. For example, I think CTFs are pretty good at that, pretty good for doing that. So just go to ctftime.org and play every CTF ever. There are CTFs every weekend, even multiple CTFs per weekend. Just play everything. The algorithm will be such as that. First, play CTF. Second, really play CTF, or just try as hard as you can. Second, read write-ups. There is a culture in the CTF community that teams publish their write-ups, which are explainers on how the challenges were done. Third, and which is the most important part, reproduce. I don't mean размножайтесь. I mean reproduce the steps in the write-ups. Try for yourself to do the same thing that the write-up author has done. So I think that will be a universal thing to become good. But I don't need
The first is go to line 1.
Yeah. Go to 1. 5th is this. 6th is profit.
Mhm.
Here is the full algorithm.
So the
Okay.
profit is unreachable, right?
Once you become hacker enough to skip the go-to in an endless loop. Alrighty. So, next question.
What about web
Oh, web.
challenges? I
Um,
guess
I do. Uh-huh.
there are 4 reversers here, I guess.
Yeah.
Mostly.
Well, because you guys are reverses, so you have given some reversing tips. About web, I don't know. Actually, I don't know. I think there is some hack this site or something website. Well, there are lots of, I think, war games dedicated to web. Also, by the way, for web, I think some guys recommend to read bug bounty reports. I have not tried it myself, but try to read bug bounty reports to keep an eye on the latest bugs.
We have
latest
over
findings.
the right.org.
Over the wire.
The wire.
Oh yeah,
Especially
those are
not as
for
game.
Pwn. It's not for Pwn only, right?
Hmm?
It's not only for Pwn, for binary pawning, right? No, binary pawning.
We have over the wire Bash,
Okay.
Natas, and many other courses.
Great. So here are war games on web, Linux, crypto, Pwn. Yeah, really. I have not realized that. So that would be the answer. Next question. What technical difficulties you faced making a CTF like this? Well, the main technical difficulties would be the infrastructure. For example, I think I can show you some secret stuff via my SSH. Let me enlarge the font. Okay. So, for example, when we do connection to the Netflix server, let me show you what happens. Let's provide our team token, which is somewhere at the beginning. Okay, it's somewhere in the middle, so here it is. At this very moment, this is our connection, and this Hellish pipeline, Hellish Bash pipeline, actually has run a PHP image of the node file system. Also, it would launch a KVM virtual machine, which will boot from that iSCSI target, and it will launch a Docker that you get access to, this Docker. It's not only a PHP script that's doing that, it also spawns a new PID namespace, so that once any of those components dies, for example, once QEMU dies, let's kill QEMU, all 3 components die. We killed QEMU, but we also lost control of the Docker. Also, for the convenience of our players, if the same team connects with the same token, okay. Well, that part broke. Those are the technical difficulties. Okay. Actually, it should show some Oh, come on. Well, okay, it's broken. Don't know why. Well, I'll debug it later. It should show some interface of like asking to rebuild the infrastructure or to attach a new session to the Docker. Also, what's interesting? Oh yeah, I also patched the Docker itself so that I added actually an option to stop and detach once you detach from a container. For example, where do we have some container? QWERTY. Oh. Once you detach from container, it kills it. So someone probably is solving the doc-esque challenge. Okay, now I'm not doing exit. I'm doing Control P, Control Q, which detach this container, and it would leave the infrastructure running in the background. But we see that it's not running because, well, I patched into the Docker daemon a flag stop and detach, which removes the container once it's detached. Apart from infrastructure, I don't know. Well, the challenges are fun to make, like to brainstorm the ideas and make them. That was the second question. Oh yeah, we got a reflection DDoS on our infrastructure during the CTF. Some maybe that's like very 2020 thing to have some schoolboys having control over the botnets that can just exhaust your gigabit network. Well, DNS amplification was there, CLDAP amplification was there. Well, schoolboys with botnets. Well, what can we do? Next question. What has happened here? We see someone connecting to docesc, doing Control-C, and getting some error. Well, that's pretty straightforward. Let me grab a docesc token. Oh, wait, no token here, just the password. And if I press Control-C just at the right moment, okay, let's kill it. If I press Control-C just at the right moment, not at this moment. Oh. I'll try a couple more times. If I'm not lucky, then I'll stop trying. Looks like I'm not lucky. But that actually just is Docker run. Just like that. Alpine SH starting on the connect to docesc. And once you have pressed the Control-C, it actually sent a signal to a start in Docker. Maybe I will be able to reproduce it locally. Okay, like that. I sent a interrupt signal to a start in Docker, and there happened some exception, like in the Docker client, because it did not expect to receive this signal, and it just printed the exception. Alrighty. What's next one? Oh, next question is, when's the next one? Probably next year. Also, I think we like when if we don't get the pandemic again, we'll probably make a big one again, consisting of quals round and a final round. So I think that's a wrap on the CyBRICS video write-up session, aka task analysis. Thank you everyone who was watching this. If you enjoyed CyBRICS but did not yet leave like your feedback on the Google form and have not yet voted for CTF time wait, please do on ctftime.org. Wait voting. Again, congratulations to the winners. BioPlus asks, is there any info from last year's attack defense? I think we have not published any info, like except the results from the last year's on-site round. So only the results are available, I think. Finals results. Well, it's not too useful for you, I guess, but that's, I think, all we have published. Oh yeah, there was some great firewall. It's true. Thanks, guys. Thanks to Stas, Yegor, Artur for joining us today to explain challenges. And let's wrap up.
Okay,
Bye-bye.
bye.
Bye-bye.